All right, good afternoon, everybody. So this recording is because we had the internet outage. Hopefully this reaches you without an issue. And this will not mean that we are still testing on Thursday. This just means that you have access to the information and then we will review it on Thursday. So, this is where we left off. We did finish filling this in. I can't print it because the internet's still down, including the intranet with the computer to the printer. So, binomial probability mean and standard deviation. We left off here, find the mean and standard deviation of x, and we're focusing on this probability, 0.2. So, for the mean and standard deviation, the mean is 6 times 0.2. Because we're told right here that B tells us that we've got binomial. 6 is our n. And that letter variable P right there is the probability of success. So, to find the mean, we put those two together. The standard deviation, same thing. Standard deviation, 6 times 0.2 times 0.8. So there's part 1. Next, graph the distribution using a column graph. So I didn't get to describe it much in detail, so I'll do that now. But the column graph is literally going to track out the events of 0 successes, 1 success, 2 success, 3 success, 4 success, 5 success, and then the max 6 successes. And then over here on the y-axis, we'll have the probability of those successes. So I'm going to go ahead and put what I come up with. I think I'll do 0.5, 0.4, 0.3. Oh, clearly I did not space this out well. Let's try it again. I should have worked from the bottom up. That's okay, easy fix. 0.1, 0.2, 0.3, 0.4, 0.5. And what we're going to do is find the probability of 0 successes, 1 success, 2 successes, 3 successes, 4 successes, etc. And we find each of those by putting them in as binom, PDF, NPX. Binom, PDF, NPX. And that one is on its side, so that's hopefully clear that that is our x. Binom, PDF, 6.2, and then 2. Binom, oh my gosh, this is so repetitive. 6.23. All right, etc. All of those are going to be found with my calculator, which is all the way over there. So, basically, I'm going to go ahead and put them in my old TI-83. And I've already done this, so I'm just going to clear it and do it again. Second distribute, binom PDF, and the probability from 6 trials with a 0.2 chance of success of getting 0 successes is 0.262. All right, 0 successes actually isn't that unlikely. So 0.262, we'll put it right about there. All right, 0.262. All right, now I'm going to do it again. So that's a little trick I used. I press second enter to repopulate the previous entry. And then I can go back and edit it so that it's 621 or 0.21. And that is 0.39. It's going to be right up next to the 0.4 bar, 0.393. All right, I'm going to keep doing this again. 2, 0.245, so 0.245, 3. Oh, we're getting low here. All right, 3. Yikes, that's not even at the 0.1. All right. 0.082. All right. Let's try 4. Oh my goodness. 0.015. 5. All right, that's like not even on the graph. 0.002. 6 is going to be crazy. Here it is. Yep. 1, 2, 3, 4, 5. That -5 means that we are 5 spaces to the left of that decimal. So we have to take that decimal and go 1, 2, 3, 4, 5, which fills in 4 zeros in front of it. So there's our column graph of the data. And let's talk about the shape of this. This is extremely skewed to the right. All right, this is extremely skewed to the right because there's a large quantity here on the left, but then as we go over to the right side of it, it drops down very, very quickly. So this is not going to be appropriate to use a normal distribution on. This cannot be approximated with a normal distribution, which hopefully you remember the properties of, one of which is that it has to be symmetric. This is not symmetric, so we can't apply a non-symmetric data to a symmetric graph. What we are going to look at, though, is what would create a situation where you could approximate this with a normal distribution. Well, there's a couple of things. One, your probability would have to be fairly symmetric probability, or 2, your cases would have to be very, very frequent. So only 6 cases is not going to create a situation in which we'd have a normal symmetric looking distribution of counts. Right here we have a very asymmetric, very skewed distribution of counts because we only have 6 cases and a very unequal probability. So that's going to change things. It's going to make things a little bit different. And then on the next page over, you will hopefully see a little bit more explanation as to why.